So we're not doing this. We are going to do this. All right, so scientific notation. So the weirdest one is -6. Right, -6 is going to be -6 times 10 to the 0 power, right? It's not going to change. Yeah. So those two match. How about 0.6? That's going to be this one, right? 6 times 10 to the -1 power, right? Why? Because we moved the decimal over 1, right? All right, so we got those. Let's look at this one. How far do we move the decimal over to put it in scientific notation? We go 1, 2, 3, 4, 5, 6. So these two match, right? My bad. How about negative? Since it is a decimal, we got to go there. My bad. How about this one? How far did we have to move the decimal? 1, 2, 3, 4, 5. So these two match, which means that these two match, right?
Hold on.
Yeah. You have to draw them on a perfectly straight line? Okay. Let's do some more. So we're just going to put these things into scientific notation. So we would call this 2.34 times 10, and the way that we find the exponent is we go where our decimal was, right? We go 1, 2, 3, 4, 5, so it's times 10 to the 5th. With this one, it's going to be 3.5 times 10, and wherever we put our decimal, we're going to count back to where it is, 1, 2, 3, and because it's a decimal, it's going to be to the -3. Because we have a number less than 1. Yes. To the decimal, yeah, to where you're putting your decimal. So I'm going to put my decimal here at 5.321, right? And so I'm going to count from where my decimal was here. So 1, 2, 3, 4, 5, 6, 7, 8. And it's going to be positive. This one, 1.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And it should be negative, right? Because we have a number less than 1. How about 3.31? 331.
Won't change.
No, it's not. And how do we express that without a change?
10 to the 0.
10 to the 0. Heck yeah, you gotta tell me. There is a formal notation there, a formal definition there of scientific notation. Shall we write more numbers in scientific notation?
I would like scientific.
For fun? Just for funsies? So we're going 5.32. The decimal is there. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th power. It says that there are 16 zeros after after the decimal point. So 16, 17, right? Because you got to go one more than the 0. And then for this one, 8.9, it says there are 14 after the 9, but our decimal is here, right? So we got one more. So it's times 10 to the 15. All right, real quick. When we count our decimals, actually, I'm gonna have that say. No, let's do it right now. Okay. So let's see if let's write something equivalent. So 53.2 if we want this to be equal to both of these things, hey. Okay, so how could we make this equivalent? Let's think about it. When we counted, so let's do it. Let's put it here and go 1, 2, 3, 4, 5, 6, 7. Okay, so that would be times 10 to the 7. So it looks like if we move our decimal to the right, it decreases our exponent, right? So when we put our decimal to the right, the exponent decreases. And if we were to move it to the left, the exponent would increase. And we're going to actually have to do that with some problems that are coming up, all right? Ready? Let's get it? Yes.
So even if it's a negative, if we move to the right, the exponent increases?
I believe that that's true. Let's check it out. So let's look. How about for this one? If we move it to the right, so if we put it here, well, that's going to wind up being positive. Let's look at this one. Okay. So if we put this, no, it's going to increase it, right? So if we put the decimal here, right? So we called it 12 times 10. And this is, by the way, not in scientific notation, right? But it's going to be important to look at. So we put it here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 10. So it's decreasing.
Oh, I see. So if it's negative, that would be increase.
Yeah.
Okay.
All right. So you could just look at it if you're going to make a rule. If you move it to the right, it's going to either become more positive or make it negative, depending on whether it's positive or negative. Okay. Moving on. I don't think we need to do a bunch more of these. Let's go ahead and get to this problem. Okay. Distance from the sun to the earth. So it says that we're going to express our answer in scientific notation, which means that this d, by the way, right, is always the ones place. So when I wrote like 51 times 10 to some power, that wasn't actually in scientific notation. I was just having us look at what happens when we move the decimal. And d is going to be rounded to the nearest 10. So for our distance from the sun to the earth, I'm going to call that 1.5, that's rounding to the nearest 10, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. So, boom. Distance from the sun to Jupiter. Here's the distance between sun and Jupiter, so we're here. So it's 7.8 if we're rounding to the 10th place. And then we go 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the 8th. Distance from the sun to Pluto. We're going to go 5.9 if we're rounding this here. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be times 10 to the 9th power. All right, now we get down to the nitty-gritty. We want to know how much farther Jupiter is from the sun than Earth. So we got to do Jupiter minus Earth, right? Jupiter minus Earth. So 7.8 times 10 to the 8 minus 1.5 times 10 to the 8.
Yes, sir.
All right, check it out. I can just subtract these coefficients because it's like they're like terms, right? So imagine if I had 3 x to the 8th minus 2 x to the 8th. These are like terms, right? Because my x's are to the same exponent, right? Like you can add x squared and x squared, but you can't add x and x squared, right? So this is just going to become 1x to the 8th, or x to the 8th, right? We're able to do the same thing with this. So I'm just going to be combining these two coefficients, right? And that's going to give me 6.3 times 10 to the 8th. And I'm going to leave that 10 to the 8th the same. And that's the way that we're going to combine them.
What would we do if like the exponents were different?
That is a fantastic question. We're going to do that right now. All right? So Pluto and Jupiter. So that means I got to go Pluto minus Jupiter and now we have that problem, right? These exponents are different. So, we have to make them different. And we're going to do what I was talking about over here. So that's why I was talking about doing this. Because that's what we're going to have to do, right? We're going to decrease one of our exponents. I'm sorry, let's increase one instead. So we're going to go back. We're going to go the other way. We're going to increase one of the exponents. So, let's go ahead and increase this one. So how about this? How do you feel?
So we make it 78.
Let's use 0.78 instead. So we're going to increase it, right? See that? If we move the decimal over one more, we're counting one more, right? If we're going to count in that direction. And so now we're good. And I didn't put the 10 to the 9th there. I'm sorry about that. Minus 0.789, 10 to the 9th. And now we're allowed to subtract those. So 5.9 minus 7.78, I should say. So you have 5.12 times 10 to the 9th power. Cool. We're going to do that a few more times with a few different, we're just going to actually do the calculations, right? Okay. Yeah, this lesson is not that.
It's just scientific.
All scientific notation. We're not going to do number 8. We are going to do this. Yeah.
You have done it the other way.
You could, but
59.
you wind up doing an extra step because you wind up with a number in your tens place. So then you have to move the decimal again. So, for instance, we have the 20th and the 21st power. Okay? It makes more sense for me to increase this one than it does for me to decrease this one. If I decrease this one, I wind up with 45, right? And then when I add them, I get 47.4. And then I have to move the decimal back over to make it 4.74. So what I'm doing is saving a step. Cool? So if we decrease this one to make it 0.24 times 10,
Which one are we doing?
A from example 2. And we're going to the 21st power plus 4.5 times 10 to the 21st power. I just wind up doing less work.
Oh. Where are we? Oh, I see.
Okay. So let's add those. That gives me 4.74 times 10 to the 21st. Do you want me to do it the other way just so you can see that there's an extra step?
No, thank you.
Okay. Yeah, try when you're trying to make these the same exponent, do it so that you get a decimal less than 1, rather than getting a decimal where you have a value in the tens place, because then you'll wind up doing extra work. You don't want to do the extra work. All right, with these, we are going to wind up using, so we're multiplying, right? There's no addition sign. We are multiplying. A lot of people make mistakes when they're doing these, and the mistake that they make is that they wind up trying to add up. We're multiplying. So I can rewrite this is all multiplication as 7 times 5 times 10 to the negative 9 times 10 to the 5th, right? And now we have our properties of exponents. We know that this is 35. And our properties of exponents tell me that we can add these exponents since they have the same base. So this becomes times 10 to the negative 4th power. But the problem is that this is not in scientific notation because this has to be 3.5 times 10, right? And imagine that the decimal was here, right? If I move it that way, what's going to happen to
It increases.
my power? Well,
Like, it increases. Negative.
it goes more negative, right? Is that what you mean, right?
Or
Or
going to say, let me go more positive.
no, it's going to go. Sorry, it's to the negative 3rd. It increases, right? But decreases
Negative.
the negative, sort of, right? Yeah. Technically, increasing. All right. Cool. So with this one, I can separate it as 1.2 over 3 times 10 to the 15th over 10 to the 7th, right? Put 1.2 divided by 3 in my calculator. .2 divided by 3 is 0.4. And that's going to be times 10 to the 15 minus 7 or 8th power. But it is not in proper scientific notation because I need to move the decimal over this way, right? What happens when I move the decimal in that direction?
It's smaller.
I should decrease this power. Okay. We're going to get this done. It's going to be awesome. Okay. Let's do one more subtraction problem. So here we have 1.42. Actually, let's wait. Let's go ahead and figure out which direction we need to move these powers, right? So if I'm counting this way, right? Let's make this one lower though instead. Yeah? So that means this needs to go 1, 2, right? So this would be 0.0142 times 10 to the 13th power. minus 2 times 10 to the 13th power. Something is wrong. So with this one, let's go ahead and make this 142 times 10 to the 13th instead. That way we don't wind up with a negative number. So that's going to be 140 times 10 to the 13th. And then we need to move the decimal back by moving that to 1.4 times 10 times 10 to the 15th, since we move that over. Last two. We'll go ahead and write this as 1.42 times 2.4 times 10 to the 15th times 10 to the 13th, just reordering things. And 1.42 times 2. .84, of course. And then we're going to add our exponents, so it's going to be times 10 to the 28th power. Alright, this one I'm going to split it up and call it 1.42 divided by 2 times 10 to the negative 5th power over 10 to the 13th power. And 1.42 divided by 4 is, divided by 2, I apologize, is 71. And we're going to subtract our exponent, so this is going to be 10 to the negative 18th power. We still got to move this decimal over so that it's improper scientific notation. And what's going to happen? We moved the decimal this direction, right? Which is going to make it more negative. And we're not going to estimate how many times longer it is. That's going to finish it off. Thanks for watching.